Here's another reaction of an alkene. As you can see here, we are going to be adding water to an alkene. So we're going to be adding water across a double bond. This reaction is called hydration. Our starting molecule has 1, 2, 3, 4, 5 carbons in it and a double bond, so this is pentene. And the double bond occurs at carbon number 1, 2. So it's 2-pentene. When it comes to alkenes, we need to establish whether or not they are cis or trans isomers, if that's a consideration, and in this case it is. We have our carbon chain coming in from the bottom and then going out from the top. So we're transferring across the double bond. In this case, we know that there's a hydrogen here and a hydrogen here, but the carbon chain comes in the bottom and goes out the top. So this is trans 2-pentene. In order to perform a hydration reaction, we do need an acid catalyst. And so we'll signify that by simply putting H+ in above our arrow. So we have our acid catalyst. Now we're going to draw the products. So we're going to be adding water across this double bond. We need to know where. So water, we can think of water as being HOH. So the H is going to go one place and the OH is going to go one place. We need to figure out which side the H goes to and which side the OH goes to. If you watched the previous video where there was a Markovnikov rule addition using hydrohalogenation, we need to look at how many H's are on each carbon and how many carbons are on each carbon. When it comes to water, adding water, we use the same rule. The H adds to the carbon that has more H. In this case, both carbons have the same amount of H. Okay, and both carbons are connected to 2 carbons. This carbon has 1 carbon, 2 carbons, and 1 hydrogen. 1 carbon, 2 carbons, and 1 hydrogen. So because the 2 carbons are equal, we're going to have 2 products. So what I will say is that if carbons in the double bond are equal to products in hydration. Okay? And also there would be 2 products in hydrohalogenation as well. So we're going to draw our 2 products. The carbon chain does not change except that the double bond is gone. So the first one that I'm going to draw is based on pentane. So we have 1, 2, 3, 4, 5. And I can add my OH right here. And therefore we've added an H here. So instead of there just being 1 hydrogen, there are now 2 hydrogens. And this will be produced at approximately 50%. And then my second product, also pentane based, and my OH will go on carbon number 3. So what I have made is 2-pentanol, and I've made 3-pentanol. So in this case, when the 2 carbons are equal, meaning they have the same number of hydrogens on them, the same number of carbons on them, we make 2 products in approximately even amounts. The 2 products in this case, in the hydration of trans 2-pentene, are 2-pentanol and 3-pentanol.